This is day 139. We're going to talk about horizontal vertical shifts of trig graphs. So remember back in the day, like for example, like our quadratic graphs, we had like y times a times x minus h squared. Remember this vertex form? What did h and k do? Turn to your neighbors and tell them what h and k did and remind them of that. So what did h do, everyone?
H determined left to right.
Good, h determined left to right. That's right, Jonathan. Good job. So it changed your x-axis, right? And then remember, h was like its own little variable, so it's like a positive variable, but it's being subtracted in the equation. But the bigger h got, the farther to the right it got pushed, right? It got translated. The less or smaller h was, it became negative. It translated left, right? Remember that? And then k makes it translate up and down. So today we're going to be translating those graphs that we've been working on in trigonometry for the last couple of weeks. Did I do this right? Oh yeah, we're good. Okay, so here are the steps. Now notice that I added the standard form of the sine graph. I added some things. So remember A, what did A do? Nope, turn to your neighbors and tell them what A and B are really quick. What did A and B do?
No, the B.
Okay, so what does A do again, everyone? Seth? Up and down, right. It stretches it, right? So the bigger the amplitude, the louder the waves are. The smaller the amplitude, it gets closer to 0, right? Right? Amplitude. What about B? What does B do?
The narrow period.
Good. It changes the period. Narrow. So the bigger B gets, the shorter the period gets, right? Does that make sense?
Yes.
And we used B yesterday, the period, to figure out the frequency, but we don't have to worry about that today, but keep that in the back of your head. So what do you think C and D do then? If H and K move it left and right and up and down respectively, what do you think C and D do?
Do they rotate maybe? Like spin or something?
No, not at all. Not rotate and spin. Good guess, though.
Maybe they can translate somewhere?
That's right, they translate. So what do you think C does?
Move it.
Good, it moves it left and right, okay? So C moves it left and right, and D moves it up and down. So right here in the middle here. Okay? C moves it left and right, D moves it up and down, okay? You might want to put this in your notes, this part. I know it's in your steps, so. Okay, and when you look at C, I want you to think in terms of degrees, okay? So put a little note at the top for me too. You see how it says C right here on all of these? You know how it says C right here on all of these? Yeah. Okay. So C affects the degrees, okay? And I want you to think about it in degrees, not in radians, but degrees, okay? So why don't you pull this out for me, please, your unit circle, and let's practice converting. Because remember, degrees and radians mean the same thing, okay? So let's do that for a moment here. So the big idea, think in terms of degrees, not radians. And, of course, what does D affect? Only what does D do? Up and down, okay? There we go. So we're going to graph each of these. I want you to pull out your on your notes, just write an X and Y axis, and then it could look rough. It's okay. It's the concept that I need you to understand here for today, okay? So why don't you pull that out? You could start writing an X and Y axis that's kind of large, not your whole paper, but pretty big. Everyone's doing that, and then we're going to start putting labels down. Okay, so this is the basic sine graph, y equals a sine of x. Before we even start, I want us to look at the x-axis. Pi over 2, pi, 3 pi over 2, 2 pi, 5 pi over 2, right? There's two ways you can look at this just for practice for today. Let's change these x-axis to degrees, okay? So we could change these as 90, and the next one's 180. What's 3 pi over 2 again, everyone? 270. What's 2 pi? Good. I know this isn't on your unit circle, but what's 5 pi over 2 then? What's the pattern up there? No. 98, 180, 270, 360, and? No. What's 9 times 5, everyone? 45. Out of 0, it's 450, okay? Okay, cool. So we're starting on this first. Yeah, what's up, bud?
What's the third?
Oh, this it goes 90, 180, 270, 360. Because it used to say pi over 2, pi, 3 pi over 2, 2 pi. Okay? I want you to be able to look at it two ways. So this could be a bit of a challenge for some of you today because you haven't really looked at it this way. Like on a test, it might show up like this. Wink, wink. It'll show up like this. Okay, so just get used to it. You want to be able to look at it both ways. Okay. And you see how the x-axis here on the left? You see how I left it as negative pi over 2?
Yeah.
Does it matter that I left it that way? No. What does negative pi over 2 really mean? Negative what? Negative 90. Good job. Okay, excellent. Okay, so what we're going to do now is we're going to graph the number 1, which is the regular sine function, right? And we did this the first day we ever did trig. So just a quick review. What's A on this example on number 1? 1. So our amplitude is 1. What is our B? 1, right? So when we figure out our period, it's going to be 2 pi over b, which is just 2 pi over 1, which is just 2 pi, okay? So it's just like normal. And when you do this, we know it's a sine function, which means it's starting at 0, okay? Did you notice that your cosine function started at 1? Okay, so your sine function is down here. And you don't have to be like, you don't have to take a long time doing this. You just could plot some points, and you could start... Oh, also, what is our C and D on number 1? I'm sorry, before I even do that. What was our C? 0, right? Was there a C in our original number 1? No, so we can mark it as 0. Was there a D on our original number 1? No. Okay, so what we're going to do is plot our points here. And we could just draw our sine curve, right? And notice how I'm just trying to make a nice curvy line. And I could go the opposite way too, right? And that's our basic sine curve, okay?
Did it start at 1? Oh, yeah.
No, we're not starting at 1. It's starting at 0 because it's a sine curve. Right? Not cosine. And that's number 1, right? This is what we all should know how to do. So everyone's doing this on your papers. That way, because we're going to do this. Notice how number 2 is going to build off number 1. Number 2 looks all messy now. Let's fix that. This is number 2. Okay. Number 2 will build off number 1, and then number 3 will build off number 2. Okay. Okay, so we didn't do any translation on number 1. This is just the basic sine curve. You should memorize how it looks, what the amplitude is, you know, what the period is, where all the marks are, okay? Now, look at number 2. What's different about number 2? Turn to your neighbors and tell them what's different about number 2.
C. Where's the D? What is it? For number 2? Where's that? Put it there.
Number 3 doesn't have it. Number 2. Number 2.
Okay, number 2. What's different about it? The C or the D?
The C.
The C, right? It's saying our C is 30, right? Because this 30 is its own number. Now, this is a positive 30. So what this is saying, these are what are we supposed to refer to C as? What? Radians or degrees? Degrees, right? So be careful. You're not going to move this whole thing to the right 30 boxes. You're going to only move it 30 degrees. So on your graph paper, it might only represent 1 or 2. So on this graph paper, notice that from 0 to 90, it's 5 boxes. So 30 degrees to me, it's about 1.5 boxes, because each box here, it represents 18 degrees on my graph here. Okay? So what I'm going to have to do is approximate. So this is how I'm going to translate it. It's saying x minus 30, and I'm going to use a different color. Okay? So notice this point here at 0. I'm going to translate it to the right 30 degrees. Okay, ready? So I'm going to make a new graph. This point here, I'm going to move it to the right 30 degrees. Where is it? What's going on up here? So I'm moving this point, first point, to the right 30 degrees, so I'm plotting a point here. Then I'm going to take this next point, move it to the right, and the following point, move it to the right, and the following point, move it to the right. Okay? Notice that I took each of these points, moved it to the right 30 degrees, 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 and moved it to the right 30 degrees. You all see that? Give me a thumbs up if this made sense, or thumbs down if you want me to explain it again. Okay, again, so this original C right here, C is x minus C, so it's telling me to translate it 30 degrees to the right. 30 degrees, right? Not 30 boxes, but 30 degrees. Does that make sense? So over here I took each of my points from my original graph, and I know this is my parent function, I'm going to move it to the right 30 degrees. So I took each of my points that I started with, moved it to the right 30 degrees. There's a point here, moved it to the right 30 degrees, move this point to the right 30 degrees, this point to the right 30 degrees, move this point to the right 30 degrees, and move this point to the right 30 degrees. Okay, does that make sense, everyone? Yes? Okay, cool. And I'm going to do that for the rest of the graph here. So, and then I'm just going to draw my curve. So notice that my number 2, I put it in red so that you could see the translation of the whole graph. From the blue to the red, it just shifted over 30 degrees. Okay? That's how you graph number 2. Any questions on number 2? Okay, so let's hear, since it's Thursday, let's have our 4s. All my 4s will be Cassidy, Michael. The rest of you that are a 4, you're going to explain how did I translate the blue graph to the right 30 degrees so it turned out to be number 2. Okay, ready, set, 30 seconds, go. That's what C does, okay? Now what if it said like x plus 30 at the top here? What would you have done instead? Yeah, we move it the other way. What's it when we do x plus 30? That's like me saying x minus a negative 30. Would you agree with that? Uh-huh. Yeah, so we would move it the other way. Okay? Good. So when it says x plus 30, we could read x plus 30 a different way. We could say it's like saying x minus a negative 30. See up there? No, we take the original blue one and we move it back 30 degrees. Right? Y'all good with that? Okay, cool. Just want to make sure you understood that. Okay, last one. Number 4, what do you notice what's different on number 3, everyone? What's different about number 3? It's got the plus what?
2.
Plus 2, right? On number 1, do we have a D?
No.
Yeah, we do. What's our D on number 1?
0.
Okay, cool. So D is super important. Ready? D gives us this thing called a midline. Did you notice that this is kind of looks symmetrical or has like a middle place where it tends to hang out originally?
Yes.
It's called a midline, okay? So like the original, I'll go back to my blue color. The original blue graph had a midline right at 0, right? Y'all see that? And the red one also had a midline at 0. What's D equal to in numbers 1 and 2? What's D equal to in number 1 and 2?
0.
0. You see how there's a midline at 0?
Uh-huh.
Okay, what is the midline at number 3?
It's 2.
2, right? So that means I'm going to take the red and blue line, I'm going to move it up to 2. So I should have a midline up here, right? And it looks really messy because I'm trying to make a point here. Does that make sense?
Yes.
So, did you notice on number 2 that I took each point and moved it 30 degrees to the right on each one?
Yeah.
What do you think I'm going to do on this one?
30 degrees to the left.
2 up, right? Do I need to worry about degrees on this one? No, I just count 2 units up, okay? So on my graph up here, units, I have to count up carefully 2 units up. Okay, so we're going to start off with, oh, by the way, what's similar on number 3 that's similar on number 2? They both have 30. So what I'm going to do is I'm going to pretend I know that. I'm going to start off with the red graph we made on number 2, and I'm going to use those points to help me move up, okay? So all I'm doing now is I'm going to take each point, right? I'm moving this point up. So just to give you an idea of what I'm doing, taking this original point from the red, I'm going up 1 unit, 2 units. And you see how there's a point there now? Or this red point here, 1 unit, 2 unit. There's a point there now. You see that? Or this point right here, 1 and 2. Does that make sense, everyone? Okay? So, and then I do that all the way across, and we have our graph right here, which is our translated graph, right? So, again, you always want to start with understanding what the basic blue one looks like. You figure out, okay, if the blue one is supposed to look like this at the center with the midline of 0, and I'm supposed to translate it, then you could translate it from that point. Okay? Give me a thumbs up or thumbs down on translating it up or down based on D. Thumbs down meaning you want me to restate it. Y'all good? Okay, that wasn't very hard. That should have taken a very short time. So I appreciate you doing that. So what we're going to do now, since we lost some time, we're just going to go straight to, we're going to conclude the lesson there. So